Okay, so today we're going to be learning about an inverse of a function. And in order to start this all off, I thought we'd do a little reviewing. So do you remember this slide from before spring break? We talked about relations and functions and one-to-one. So basically you can have coordinates, you can have a table, you can have a graph, or you can have a mapping notation, but any of those are relations. But in order for the relation to be a function, every input has to have one output. And if you're going to be a one-to-one function, then every output has to have one input. And just recalling domain and range, so domain was x's, range is y's. And we kind of looked at some of these, like this first one over here. That one's good. That one is a function because every single input has one output. Whereas number 2 here, we look at this input 3 has 2 different outputs. So that's not a function, okay? If it's not a function, then it can't be one-to-one. The last one down here is number 3 here. This one definitely is a function, but if you try to tell if it's one-to-one, when you go in reverse, this 0 is going to have 2 different outputs. So although this one is a function, it's not one-to-one. Okay? We also had 2 tests to tell if something was a function and if it was one-to-one. We remember the vertical line test. You can draw a vertical line. If it touches one time, then it's a function. For a horizontal line test, though, you want to go, if you go this way, horizontally, you can see that that one's going to cross twice. So that would not be a one-to-one function, because what's going to happen when you go to do the inverse, then every input will have 2 different outputs. So all this is a function. It's not one-to-one. Again, this one here is not even a function because it touches too many times. So this is not a function, and it's also, we can't even check for one-to-one. Down here, the line, it's passing both vertical line tests that way, and then it also passes the horizontal line test. So this one is a function, and it is one-to-one. So that's just a little review of stuff we did before spring break. Okay, so the new part today is an inverse relation. So that's what we get when we exchange the domain and range. So what that means is you're going to take the x's and the y's and you're going to swap them around. Okay, so here's a very basic one. We got a set of points. This relation would be a function because if you look at all these x's, every x has one y matched to it. So every input has one output. So if I want to do the inverse, all I need to do is interchange the domain and range. So I'm going to have 1, 2, and then I'm going to have 7 with 4, and then I'm going to have 6 with -3. And then I can determine if it's one-to-one. So if I look at this, every input still has one output. So this is a function, and it's also one-to-one. The symbol for an inverse is this f to the -1. So if you're seeing that, or it could be a to the -1, b to the -1, whatever it is, to that -1 power, that's letting you know you're doing the inverse, which means it is the interchanging of the x and the y's. So let's look at what happens graphically, and we're going to take this quadratic here, and I'm going to make a little table of values. So if I put in a -2, I would get out 6. If I put in a -1, I'm getting out 3. If I put in a 0, 2. If I put in a 1, whoops, I get out 3. And if I put in a 2, I get out 6 again. Okay, so let's go look at the graph of that. So I've got -2, 1, 2, 3, 4, 5, 6. I've got -1, 1, 2, 3, 0, 2, and this should be very symmetrical. So I got this nice little parabola going, and +2 we know is moving the graph up 2. Whoops, I kind of missed that last point. Let's try that graph again. So there's our parabola. Okay. Now, if I want to find the inverse of that, I will exchange the x's and the y's. So let me pick a different color. So now my x's, or my y's from this graph, will now be my x's. And the x's here will now be my inverses, my y's. Oops. Okay, so let's see what happens when we graph this one. So 1, 2, 3, 4, 5, 6, -2, 3, -1, and if we go symmetrical, voila. So look what happens when we do the inverse of our quadratic. So instead of being y equals x squared plus 2, we've had to reverse the x's and y's, and it does turn your parabola sideways. Maybe some of you that did the piecewise project realized that. Okay, another key thing here. This original graph, when you do the inverse of any of them, gets reflected over this line. y equals x. Okay, so if we reflect that over the line, y equals x, that's another way to visually see your inverse. Another key point on this parabola one, we know that the original one is a function, but we also know because of the horizontal line test, it's not one-to-one. And we can see that now when we look at the inverse. It's not one-to-one because if I kind of draw my vertical line, this value here would be matched up with two different y values, okay? So if you do an inverse on something that comes out not one-to-one, sometimes you might see a limit of the domain. They might say do this, but only for x is greater than or equal to, say, 0. Okay, that way you only get a portion of it. So if we only had a portion of that parabola, then it would be a function when we found its inverse. So if you see some things like that where they limit the domain, the reason they're doing that is just so that the solution to the inverse also works out to be a function. Just FYI. Okay, so let's try to do a couple examples here. So let's say we have this first one here and we want to find the inverse of this. So f of x is like a y. So the first thing I always do is change it to y. And then the second thing is what an inverse is. Interchange the x and y. So I'm going to put x on this side. I'm going to put y on the other side. Notice I did not touch the 3 and the 4. They stay where they're at. I'm just taking x and y and swapping them. The last part is now you have to solve for y. So I'm going to subtract the 4 over, divide by that 3. Okay. You can write this answer a couple ways. I'm fine if you write it like this. You might also see it if you're taking an ACT. They might write it as separate fractions. Okay. So you could see that written as one fraction or separate. So I'll let you kind of decide which way you want to do that. So I want you to pause the video and I want you to try number 2 here and see if you get the same answer I get. So hit pause. Okay, let's see how you did. So this one, we're going to switch it. Now I'm going to interchange my x and my y. And now I just solve for y. So I can leave it like this for the inverse, or I can make separate fractions for the inverse. So how did you do? Did you get one of those two answers? Okay, again, that f to the negative 1 is the symbol for inverse. Okay, let's look at a couple other functions. So this one is a square root. Again, if you want to hit pause and try it, not a bad idea, and then you can kind of see how yours is comparing to mine. Okay, so I interchange the x and y here. Now to get this by itself, remember when we solve radicals, you got to isolate the radical. So I got to start by moving that 8 over. Then I got to get rid of that 2. So what undoes a 2 is dividing by 2. Okay, now I got to get the square root, undo that. So I got to square. Now, when you're squaring that whole left side, you got to use some parentheses there. So now I'm down to x minus 8 over 2 equals y minus 5. So last step, add over that 5, call it f inverse of x. Oops, did I forget my square there? There we go. So x minus 8 divided by 2 squared plus 5. If you look at this, any of these compared to the original, you will see it's literally the opposite of everything you had. See how we have a plus 8 here? We have a minus 8 in our answer. We had timesing by 2 here, but in the answer it's dividing. This one had a square root, but notice the answer has a square. This minus 5, notice it's now a plus 5. So it's a kind of a quick check to see if you did it right. Like, do you have the opposite of everything that's there? I would not try to do too much in your head. Literally write this out. You'll be more successful. Again, if you want to pause, normally in class I would make you guys try these and then we would check our answers. So hit pause, give it a try, and then come back and see how you did. Okay, so I've got y equals 5x cubed minus 9 if I swap the x and y. And now I'm going to add over the 9 and divide by that 5. And undoing a cube, I've got a cube root both sides. So I've got that whole thing in a cube root. So if you check your answer, Up in the original problem, we had -9 and your answer +9. This was times 5 and the answer is divided by 5. This had a cube. Notice the answer has a cube root. So it's all kind of the opposites of what we've done. Okay. Again, I'm just going to do a couple more. If you kind of got it and you're done, don't need any more examples, fine, but I am going to show you a couple more. So this one here, again, swapping, and then I would add over the 7, and then I would undo the square. Now, technically, when we square root this, we do get plus or minus, but if you do both plus or minus, then you're going to not get a function. So I'm only going to do the positive, okay, just to have a function. Here's one. So this one's a fraction one, huh? Well, to undo a fraction, you always got to multiply what's in the denominator. Okay, so these are like cross multiplying, maybe is a good word to use for that. And then add over the 9. So 2x plus 9 equals f inverse of x. Okay, so it gives you a couple more examples. This next little part is only for honors. So if you're non-honors, this hopefully gives you enough so you can go try the little Google slide and the Google form. Okay, if you are in honors, we need to do verifying inverses. So if you want to tell if two equations are inverses of each other, you got to do VAhonors and Goff, and they both have to come out to be x. If you don't get an x when you're doing this, then it's just not an inverse. So I'm going to come over here and do f of g of x. So that means I got to take g and substitute it into f. So all of this has to go here. So I'm going to type in my 4/3 x plus 8 minus 6. Okay, I'm going to do some distributing. 3/4 times 4/3 is 1x. 3/4 of x of 8 is 6. 6 minus 6 cancels, so I got an x. That's a good sign, but you do have to do it the other way around just to make sure. Sometimes one way will work and the other doesn't. Again, we're trying to get them to be x's. Let me try it. G of f of x. That means I got to take f and substitute it in for g. So all of this needs to go here. So, oops, started off 4/3. So I got 4/3, and then I'm going to have 3/4 x minus 6 plus 8. Well, if I do some distributing here, 4/3 times 3/4 is x. 4/3 times -6 is -8, and -8 plus 8 is x. Okay, so that's called verifying inverses. It's actually one of the reasons that we do teach you VAhonors and Goff. So this part is only for honors, so if you're in non-honors, you don't have to worry about it. I guess that's it for today. So you're good to go. Get your Google form and